I'm going to skip to the second page. We'll come back and do the review portion of the beginning at the end of the video. The new stuff that we're going to learn today is called factoring by grouping. It's probably the least used factoring that we'll use. It's more of a tool that we will use later in a different kind of factoring. Page 302 in the book gives instructions for factoring by grouping if you need more help. So here are my instructions for factoring by grouping. Example 1. If you have this problem and you are supposed to factor by grouping, the first thing you do is split it into two groups. So I've split it up into 2x squared plus 6x and positive 5x plus 15. Step 2. GCF, or take the greatest common factor out of each group. So in this case, there's a 2x in common there. So I pull out that 2x and then put my leftovers in the parentheses, the x plus 3. Here I have a 5. That's my greatest common factor. So I'm going to factor out the 5 and I'm left with x plus 3. With factoring by grouping, you have to end up with, and most of the problems will be set up so that you end up with the same thing in the parentheses. So step 3 is you kind of think of it like you have two terms here. This is the first term, and this is the second term. What's in common between those two terms? Well, the x plus 3 is in common, so I'm going to GCF that out. I'm going to factor that out and put it out front. The x plus 3 gets pulled out and put in front, and then in parentheses is the leftovers, the 2x and the plus 5. And there's the answer, x plus 3 times 2x plus 5. I can distribute this to check and see if I'm right. And that matches up with the beginning, so I'm correct. Example 2, factor by grouping. So step 1 is to split them into two groups. Step 2, GCF factor each group. So let's see, I have a 3x in common in those two pieces, so I factor out a 3x and I'm left with x plus y. And then in the second group, I have a negative y in common. Now I could have just factored out a y, but then I wouldn't have had these two match up. You need to make sure that those two match up, so that's why I had to factor out that negative y. Step 3, you want to look for that common factor right here, x plus y. Those are a common factor. So again, it's like I have two terms. Here's term 1, here's term 2. I'm going to say what's in common. What's the greatest common factor? The x plus y. So the x plus y gets pulled out to the front, and then my leftovers are in the parentheses, the 3x minus y. Then we're done. Example 3. This one looks a little bit different, and it's actually because step 1 and 2 have already been done for us. All we have left is step 3. If you look, again, it's like I have two terms. There's term 1, there's term 2. Let's just GCF out the a plus 2. The a plus 2 is in common. So I'm going to pull that out to the front and then put my leftovers in the parentheses. The 4 minus b is in the parentheses, and I'm done. So I told you that this is the least common used factoring. So if I'm on a test, how do I know if I should use factoring by grouping? I might tell you in the instructions. So always remember to read the instructions. Otherwise, look for 4 terms. That's a good indicator that factoring by grouping is a good method to try. Why are we learning this if it's not used very often? In 2 class sessions, we will be factoring polynomials that look like this, ax squared plus bx plus c, and we're going to use factoring by grouping when we do that. So we're trying to build toward that topic today. Let's try a few examples. Feel free to pause the video and try them on your own first if you want to. Example 4. Steps 1 and 2 have already been done for us. We just have to do that final step. Again, it's like I have two terms. So I'm just going to GCF out what's in common. The x plus y is in common, so I'll put that out front. And then in the parentheses, I'll put my leftovers, which is 4 plus t. Done. Example 5. I've already started with step 1, which is to split up the two pieces. Then in each piece, factor out the GCF. So in this piece, my GCF is c. And then in the parentheses are my leftovers, 3 minus d. And then in this piece, d is my greatest common factor, and I'm left with 3 minus d in parentheses. Again, I want to make sure that these two pieces match up. So then my last step is to take my two terms that I have left and factor out the greatest common factor of 3 minus d. So I'll factor that out. And then c plus d are my leftovers. And there's my answer. We will now go back to page 1, which is the review. If you do not need review, you can stop at this time, or you can fast forward to the end to see if your answers are correct. So I've set this problem up with this under the house. So now I want to know how many times does x go into 3x cubed? 3x squared. Or another way to think about that is x times what would make 3x cubed? Then I distribute or multiply, so I get 3x to the third, and then I multiply that minus 6x squared. Then I need to subtract, so that turns negative, that turns positive. 8x squared. Bring down this negative 3x, and then x times what makes 8x squared? Plus 8x. And then distribute the 8x with this. So 8x squared minus 16x. And then subtract. So I get 13x. Bring down the plus 8. So x times what makes 13x? So plus 13. Then multiply 13x minus 26. Then subtract, so this will turn positive. So that's plus 34. That's a 4, sorry. So I get plus 34 over x minus 2. There's my answer. When I'm multiplying, I'm going to multiply this term times this. Remember that when we multiply a's, like bases, we can add those exponents. So when I multiply here, 2 times 4, I'll get 8. And then a to the 7th, add the 4 and the 3. And then this is b to the 1st, so that'll be b to the 5th, b to the 1st, that's b to the 6th. C to the 9th. Then I'll distribute to this term. So that will be minus 12, a to the 12th, b to the 6th, c to the 5th. Okay, down here I need to distribute, so I'm going to distribute everything in this parenthesis by everything in this parenthesis. I check for like terms, but there are none. So far we have worked with one type of factoring. I call it GCF factoring. You look at your two terms and find what's in common that can divide out of both terms. Okay? So 8 and 12, there is a 4 in common. I can divide 4 out of both of those. And then I look at the A's. Well, there's a to the 4th in common. Then the B's, oh, all the B's can go. B to the 6th in common. And then C to the 4th in common. Then in the parentheses, I put my leftovers. So when I divide a 4 out of there, I'm left with a 2. If I divide a to the 4th out of there, I will have a to the 4th left. When I divide b to the 6th out, that's gone. And I divide c to the 4th out, that's gone. So there's my first term. Minus. Okay, again, when I divide 4 out of there, I'll have 3 left. When I divide a to the 4th out, that will be gone. When I divide b to the 6th out, that will be gone. When I divide out c to the 4th, I'll have c squared left. And then always check your parenthesis for another factor that you may have missed. But those two are relatively prime, so I'm done. That's my answer. Again, how would I check this? When I factor, I am just unmultiplying or dividing. So to check this, I would just distribute, multiply, and I should come up with that answer again. Number 5. Let's see. What's in common? There's a 3x in common. So I'll put my leftovers in parentheses. When I divide out a 3x divided by 3x will be 1. So if there's nothing left, if both of these things are taken out, then you need to put a 1 there. Minus, okay, divide a 3 out, you get a 3. Divide one of the x's out, you'll be left with x squared y.